Chapter 6 is going to be on exponents and radicals. Radicals for Algebra 1 just means square roots. So for 6.1a, we're just going to introduce some of the vocabulary and the basics of exponents and square roots. Okay, this is an exponent. This little number on the right and towards the top, this is the exponent part. The big number, that's normal size, this is called the base. The exponent tells you how many times to multiply the base by itself. So for example, if it's m to the third, it's saying multiply the base m times itself 3 times. So m times m times m. So over here, we're going to write it in expanded form. Expanded form is this, where you write out how many times you're going to multiply the base, and then evaluate means find the answer. So since the base is 5, and the exponent's 2, I'm going to multiply the base by itself 2 times. So 5 times 5, and when I evaluate that, I get 25. This is saying exponent's 3, so multiply the base 2 times itself 3 times. So 2 times 2 times 2, which is going to be 2 times 2 is 4, and then 4 times 2 is going to give me 8 for my final answer. The last one, the base is 3, and I want to multiply it by itself 4 times because the exponent tells me. If you can do it in your head, that's great. Let's see, 3 times 3 is 9, times 3 is 27, times 3 is 81. Or you could kind of work it as you go. I could do, okay, these 2 times to get 9, these 2 times to get 9, and if I do 9 times 9, I'm going to get 81 for my final answer. Okay, so for this example here, we're going to rewrite the expression in exponential form. Exponential form is where it has a base and an exponent. So if I look at this right here, I can see that the base is w, 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 and w is multiplied by itself 5 times. So in exponential form, this is w to the 5th. And they mean the exact same thing, but sometimes it's more concise to do exponential form. Okay, I'm going to go ahead and look at b. And see, I see it as x, x, y, y. It has 2 different bases. So let's just start with whichever base you prefer. I'm going to start with the x. The base is x. X is multiplied by itself 1, 2 times. So this is x squared. The next base I see is y. Y is multiplied by itself 1, 2, 3, 4 times, so this is y to the 4th. You could put a dot in the middle here to show it's x squared times y to the 4th, but if it's variables, when they are touching each other, it means they're being multiplied anyways. Let's go ahead and try the next one. For c, let's see what the first base is. I see a base of n, so I'm going to go ahead and write n. And see how many times is n multiplied by itself. N, that's p, that's not it. N times n times n. So n to the 3rd. The next base is p. P is multiplied by itself twice, so p squared. N to the 3rd, p to the 2nd, or p squared is my exponential form. Okay, let's go ahead and look at this next one. The first variable is a. So I'm going to put the base a. A is, and there's just one a. You could put a to the 1, or you could just write a. They mean the same thing. I'm going to go ahead and go to the next variable. The next base is b. B is multiplied by itself 1, 2, 3. So b to the 3rd. Oh, and now I have another base, c. C is multiplied by itself twice, so c to the 2nd power. And then I have this coefficient of 7. Since 7 is an actual number, the number always goes in the front, and we call it a coefficient. So even though it came last, I always put the number in the front. So 7a, b to the 3rd, c squared. The 7 has to be in front, but these 3 variables, they could be in a different order, and it would still be correct. Okay, the next topic we're going to introduce is square root. Okay, the square root of x is n if n squared is x. So I'm going to tell you what the answer is to the first one so you can see why that's the answer. Okay, the square root of 25 is 5. Okay, that's the answer. The reason it is 5 is because if I do 5 squared, I get 25. So you can do it in your head, but you're thinking, what do I times by itself, or what do I square to get that number? So for 49, what do I square to get 49? 7 squared is 49, so the square root of 49 is 7. And you don't have to show any work. If it's a perfect square, or it comes out nicely, you can just do it in your head. A square root of 144 is 12, because 12 to the 2nd power is 144. Square root of 0 is 0 because 0 times 0 is 0. Okay, now e is a fraction, but that's okay. We can still work with it. I'm going to do the numerator and denominator separately, but I'll rewrite it as a fraction. So if I just start with the numerator, I have a 9. So the square root of 9 is 3. And the denominator I have 16, so the square root of 16 is 4. So the square root of 9 over 16 is 3/4. Final answer. Okay, if I'm going to do the same, it's a fraction and I'm square rooting the entire fraction. The square root of 1 is 1 because 1 times 1 is 1. The square root of 100 is 10 because 10 times 10 is 100. So my answer is 1/10. Okay, for G, it says evaluate the square root of 8x plus 1 for x equals 10. So they want me to plug x is 10, this one in here, and evaluate just means find the answer. So I'm going to copy this. This is a square root. It has an 8. Where it has an x, they want me to substitute 10, but I'm still going to write plus 1. Okay, inside the square root, I have 8 times 10 plus 1. I need to evaluate this part first. The square rooting is going to happen last, and I'm going to follow order of operations. So 8 times 10 plus 1, I need to multiply first. Let's see, 8 times 10 is 80, and then I will plus 1. If I do square root of 80 plus 1 is 81. Okay, now that I've finished everything inside the square root, that's called the radicand, I'm going to square root the 81. The square root of 81 is 9. So my final answer is 9. Okay, I'm going to try something similar for H. Let's see, it says evaluate the square root of, and it has a bunch of stuff, b squared minus 4ac, which is, it comes from a formula we're going to use a lot this semester, so I'm just going to get you used to seeing it so you don't freak out when we get to it. Okay, I'm going to go ahead and plug it in. It says b squared. What is b? b is 7, so I'm going to put a 7 here. Okay, you don't have to put parentheses on it because it's positive, but I put them so that when I get to a negative, I don't make a mistake. Okay, now it's minus 4. So minus 4. And now they want me to plug in a, and I'll put it in parentheses. For a, it's 2. Oh, and now they want me to plug in c. c is 3. Now that I plugged it in, I need to evaluate the inside of the square root, and then at the very end, I will square root it. Okay, so 7 to the second power is 7 times 7, which is 49, minus, now they want me to do 4 times 2 times 3. I'm going to multiply all 3 together in any order, as long as I hit each one once. So 4 times 2 is 8. 8 times 3 is 24. So it should be 24. If you want to go in a different order, I could go backwards. 3 times 2 is 6. And then 6 times 4 is 24. So no matter the order, you should get the same value. And sometimes one way is just easier than the other. Okay, if I do 49 minus 24, I get 25. And the square root of 25 is 5. So after all that, my final answer is 5. Okay, the last thing we're going to introduce is the vocabulary of rational number and irrational number. Rational numbers can be expressed as integers. An integer is a whole number, but it could be positive or negative. So it could be like 3 or -2, or it could be a fraction like 5/4. All those are rational, and it comes from the word ratio, which means fraction. Okay, irrational numbers have decimals that don't repeat or they don't terminate. So if I made it a decimal, it might be 1.2457, a bunch of nonsense, and it keeps going forever, and I have no idea what the answer is. If you have a square root that doesn't come out evenly, that's also irrational if you put it in your calculator. Okay, so I'm going to go ahead and look at this and decide whether it's rational or irrational. Okay, now the square root of 36, I know that's 6. Okay, because 6 is a whole number or an integer, then this is rational. It has a nice rational answer. It didn't ask me the answer, so I didn't have to write the 6, but in my head I'm thinking, do I know the answer? Is it rational? The square root of 30, it's not 5 because 5 times 5 is 25. It's not 6 because 6 times 6 is 36. I don't know what it is. If I put it in my calculator, I actually get 5 point something, 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 something. I have no idea. It's going to be a big mess of fraction. This is going to be, not fraction, decimal. So this is going to be irrational. Okay, the square root of 3, it's not 1 because 1 times 1 is 1. 2 times 2 is 4. I don't know what the square root of 3 is. It's going to be irrational. And if you want to put it in your calculator, you can check. It'll be 1 point something, 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 and it will go forever, or as long as your screen shows. The square root of 4 is 2. 2 is an integer, so this is rational. It comes out nicely. Rational is these nice, tidy answers. Okay, this is a fraction. Let's look at it. Okay, the square root of 4 is 2. The square root of 25 is 5. 2/5 is a fraction, so this is rational. Let's try this one. The square root of 1 is 1. The square root of 9 is 3. It's a fraction, so it's rational. Okay, the square root of 2 is, I don't know, it's a big mess. Once I see part of it's a big mess, the whole thing is irrational. The square root of 7, I don't know either. Okay, let's try the next one. Okay, the square root of 9 is 3. That's okay. The square root of 5 is, I don't know the square root of 5. It's irrational. It's going to be a big decimal. Okay, go ahead and try the practice problems. When you're done, click on the link on the calendar to check your answers.